Okay, so my name is Mariya. I work at Zalando. So today I want to talk about platform design and migration in the real world, or while you have an operating business. I work in Zalando with the 3 core teams for the warehouse management system, and we design currently a set of services that is going to serve as the platform for the whole warehouse management system in the future. So we are on this journey for some time now, and I wanted to share just where we are at, what have we considered along the way, how it fits to the business, what trade-offs are there, and maybe you can take away something from that for your own migrations and for your own kind of ideas for platformization. So starting a little bit with the triggers for change, I want to go through also the methods we used when designing what we call the core platform of services, how we plan the migration, where we are so far, also what we did well and what we actually failed at and what I think we should have done better, and what we're looking forward to in the future. So this is more or less the structure. To put you in perspective of where Zalando is currently, the company has doubled its gross merchandise volume quite a few times for the 11 years it is on the market. You probably know it for the shop, you know it for the app and the clothes and shoes that it sells. But the start wasn't so glamorous. It actually started from the apartment of one of the owners, and they were just shipping shoes from there only for Germany. So when the category expanded to fashion and accessories, and also to beauty most recently, and the markets expanded to quite a few countries in Europe, currently 17, this became quite a scaled business very fast. A few years were invested into building a core of functions, not only on the tech side, but also on the business side, where we can handle that scale and where we can go to a next step of a platform strategy. So since 2015, the strategy is to have the business more serve as a platform for other partners, either selling through our website but not fulfilling from our warehouses, or fulfilling from the warehouses but not selling through the website. So those are the two main cases. And to do that, and the goal there is to have actually up to 40% of the gross merchandise volume from the partner program and from the partner business in the next 5 years. To do that, the systems need to be on par, and that's one of the reasons, of course, we decided to go to microservices. One of the core competencies of Zalando are indeed the warehouses and logistics overall. So currently that's the map of all the warehouses that we own. There are 14 fulfillment centers, 5 of them are currently getting ramped up. And last year we shipped 116 million orders out to the European market. This is only the warehouses that we own. The services that we provide for delivery and return are 60 different types of options. And if you imagine on this map the fulfillment centers and return centers and kind of carrier centers that are in the network of what happens after our warehouses or what happens after somebody returns something to our third-party suppliers. This is a huge complexity of the fulfillment network itself. Within the warehouse, there's also quite a bit of change. So if you imagine what a warehouse is like and what a warehouse management system usually handles, the main, super simplified, you have the 5 main processes of receiving goods, putting them away, and then picking them for orders, sorting them, and packing them. If all those processes get automated, of course, you have a more efficient warehouse there are still warehouses that don't have any of those processes automated. And then the warehouse management systems are quite simplistic. We have already the conveyor belt. So on this picture, you can see that there's 270 kilometers of conveyor belt in all the warehouses that we own. But this technology didn't require us to change the process so much. So there weren't so many decisions on the system side that needed to be made, even though this automation for transport within the warehouse was implemented. We also had some sortation machines that didn't require in any way to upgrade the system. The old Java monolith handled that pretty well. Where the change happened was actually with the backsorter machine. So that's a huge construction where you have the storage of items in bags, and they are stored there partially, so it has a small storage, it has small stock, and they're also sorted and put out for orders for packers to pack them. And there you already complicate the network of processes to something that needs to be optimized, it needs to work together, and you need to make the right decisions of what you put into this efficient machine in order to get the levels of efficiency that you were aiming at by buying it. So there was the first implementation with a service-based architecture, but we are actually not keeping this implementation because it wasn't designed as a platform, it was more designed only for handling this use case, and quite hastily so. So right now we had to go back to the drawing board a bit and think more at scale. What comes next? So if you think of those 5 kind of major parts of the processing of the warehouse, there are a lot of robotics that can be implemented for the optimization of the processes. One of them is this Magazzino Toru robot. So that's a picking robot that picks the shoe boxes out of the shelves and transports them to be packed and shipped. There are also the gray-orange robots. That's very similar to what Amazon is using in their warehouses for goods-to-men technologies, but out of a new company called Gray-Orange. There you have robots that move the shelves around the warehouse and bring the right shelves to the store or the picker that needs to do the task. The idea is that all this technology needs to also work with manual processes, so it needs to be safe enough to combine. And you need to make the right decisions of what goes to manual process and what goes to that. Overall, for Zalando, the whole journey to migration to microservices started somewhere 4 years ago, but for logistics, for the warehouse management system, it started 2 years ago with this backsorter machine, and let's say not so successfully or not so well planned. But you can see from where we are at right now as network complexity and as complexity of the process within the warehouse. And of course, we want to get even more automated, so the whole complexity within the warehouse would have the potential to be quite big. Then it's understandable why we wanted to move to microservices. So these are just the main benefits that are usually cited when it comes to migrating to microservices. There's scalability, efficiency, maintainability. Then you have the split of responsibilities. You can implement DevOps. If you design right, you also may have better fault tolerance. And my favorite reason for migration, because everyone else is doing it, or just because of the ease of experimentation. The last 2 here are interesting, I think, because it's not like the most cited reasons are always maintainability, scalability, how flexible the business would be afterwards, but nobody talks that much about the last 2 reasons, and we feel that very heavily in Berlin because when you are competing on a market for such a scarce resource as developers, and you're competing with just an old Java warehouse management system, it's hard to get someone to code for you. And it's anyway hard, but if we don't migrate, I think this was also one of the triggers. So how does that look like? When we're talking about breaking things down to microservices, we always have this super nice picture where you kind of separate your functions in different services and everything's done. The reality of where we are at, of course, isn't like that at all. It looks more like, for all the three teams, it looks more like this. So we do have the monolith, we have services around it that do the same things and use objects that are interchangeable, and we have sync services that sync them together. And I think we'll be at this stage for quite a while. But I think it's also kind of the right thing to do, because we can design for more functionality later on and extend with this kind of new set of services where the ideas that we want to implement with the platform are. So we try, whenever we migrate from the monolith, and implement their use case by use case to keep this kind of in check. We're still in the beginning. I think at some point we might even start just thinking forward and start thinking of maybe really deprecating part of the monolith services, but for now it's that. And kind of the spirit that we're doing this in, I think this quote very nicely sums up. I don't know if it's applicable really for any business. I think it's more applicable towards businesses like Zalando that have the ambition to grow so much and to have so much complexity and so many new services and so much optimization. And sometimes it's not so black and white, I think, but it's like super inspiring quote. So platformization. I want to talk a little bit about why we are saying that our services are a platform. Because in typical warehouse management systems, they usually are kind of a module of a whole suite. They're not thought of themselves as a platform of services and then something on it. But we would like to think about it in this way. And the reasons for it, you have one of the definitions is a set of building blocks that can be selected and combined to form new products. So, and the other one is a base where you can build new process and applications. In our context, what this means is that if we have the possibility to build these new products, we would have processes that are super flexible and hopefully can be changed quite fast whenever new automation needs to be tested or just the process is planned to be optimized by a different flow. We could create different types of tasks in the warehouse. So right now we are quite limited by the kind of expected type of task, but you could do much more. You could have different resources. So for the automation that you saw, you would have container bins for the normal conveyor processes, where you have bags for the bag automation, or you can have shelves for the gray-orange storage. And then this is, of course, combined with the processes. This also includes a little bit workforce management, which is usually a standard part of warehouse management systems. For stock, it's mainly about adding new categories and matching what we already have as categories in the warehouse to what we need to process in these different types of automation. So basically not everything fits in a bag, not everything is foilable, not everything can be put in a gray-orange storage. Some of the stuff are too valuable, have an expiration date, can be toxic. All that is super nice when it's easily extendable. We also are talking about topologies here. So whenever you introduce new automation in the warehouse, you're changing the topology, and from there the capacity of the whole warehouse, and you also, whenever you try to build new warehouses, and we're currently growing with 2 new warehouses started each year, it's much easier when you can plan them and have some idea about the capacities early on when you just deploy the whole system. What we expect on the kind of second part of the definition is that we enable the algorithmic side of things. So currently we do have an algorithmic core of 4 teams that takes care of the grouping and scheduling of tasks in the warehouse. And the more we provide them with a stable platform, the more they can elaborate on it and make more complex and more meaningful algorithms out of it. We do have a lot of clients as well. So for every process where somebody touches an item, they would have a different client. And for everything that is interaction with the automation, you would also consider it kind of an executor function. On the network view, what you saw on the overall network map, we have a lot of complexity where we need aggregated data. So there, actually, in terms of optimization from the network level, there's not much at all. And this functionality is not easily provided by any other warehouse management system. So how did we go about the platform design? So we went through 3 main steps, let's say, in thinking about it. So first of all, you can always start by checking what others did when they try to resolve this problem. Of course, there are industry standards of what is expected to be there as functionality in the warehouse management system. We have quite a few of those, but not all. So one example would be we don't currently have cartonization in shipping. This is a standard functionality for WMSs, but we don't have it because the cartonization, first of all, is knowing the kind of the volume and the type of item that you're packing. So you have a recommendation of how to pack it best, like what packaging to use, what size of packaging, and so on. We don't have that because volume measurements for clothes are quite challenging. And we also found out that the packers, because it's only mainly clothes and shoes that they're packing, already have a very good feeling about that. So this functionality we don't have, but we know it's an industry standard. At some point, if the categories grow, we know that we can expand to it. We then assessed, of course, what current capabilities we have, and also the additional ones that are neither in our current capabilities or the industry standards that we explored. So everything that is connected to the network, for example, or to error handling within processes. So of course, you have the technical considerations of error handling in the system, but within the processes, you can do quite a lot to mitigate the errors that you see there. So for missing item, extra item, stuff that you can find alternatives for easily and still fulfill the order in full. This is not really part of a standard WMS. In the second step, we try to map the process, applications, and interfaces that we now have and that we would need. So there, for example, we had one process that was planned that was actually our first project when we started with the new set of services, which is just sorting from both the backsorter machine and container bins, which when this was implemented, was cut out of the project because of the complexity, and now we were doing it for the first time with the microservice architecture. Desired are some really far-fetched stuff, like having real-time idea of what is going to be delayed or within the warehouse, and on the basis of that, or on the basis of some outages in the automation, being able to reassign orders between warehouses. And having those super nice network optimization options. That this is really, I don't think it's part of any software that's just on the market. We do have the main kind of stakeholders there. We have the executors or the clients, the decision makers, and the network. And as step 3, basically these two dimensions of what usually a WMS does and what the core of the WMS should have as capabilities kind of converge into what would be the main domain objects and what would be the main layers in the platform architecture. And that's what we found out. This is super general, of course, and it's much more services than 5. But we want to have, of course, tasks, so everything that goes in or out of the warehouse for whatever reason. We have inventory and stock and all the types there on item and article level. We have processes that do all that, so move items or check items. We have also the resources in the automation that enable the processes, the workforce and the capacities and the physical possibilities within the warehouse. And all that we have to find a place somewhere for it in this set of services, because otherwise then we're not covering our domain. So after all this thinking about how to do it, why to do it, we come to the migration itself. And I wanted to look at, again, the business justification first, because I think it's quite critical to check once again before you actually start doing it. There are two main components there. So I think it doesn't really make sense to start if you don't have new features. So if you don't expect from the business side really exponential growth that would result in this explosion of complexity that you would need to handle, and if you don't have gaps or instabilities in the current implementation. Just as an example, if we just decided that we found the perfect setup for the warehouse, we're just using conveyors, everything works as efficiently as we want it, and we're building all the new warehouse with the conveyor system, we wouldn't have needed to go to microservices. We can just replicate the whole design, and it would work, and it was stable. You don't need to do it. So I don't know how, of course, these are all super general and big questions, but I think whenever this decision is made, sometimes companies do it a bit because of the trend, maybe, and not in sync with the business always. So the reasons for, or the issues for migration, for migration failure, there are quite a few. We try to mitigate most of those. So when we're talking about decoupling from the monolith, I already showed you where we are. And for data separation, we also try to never point to the database in the monolith, but just sync the information and just keep everything nicely separated and synchronize as much as we can. There are some trade-offs there for what the visibility of operations would be. So for the systems, it's not really a problem, but sometimes when you have this sync and not everything is really there, operations would miss, for example, some of the objects that they're used to, and you would have to build a different view and maybe at some point sync forward or sync back to the old system. Yeah, there is quite a bit of challenge there, like when to make the switch. We haven't made that yet. We just have 2 views for most of the stuff they need to see. But yeah. In terms of changing people's minds and kind of expected return on investment, I think the interesting thing that I found here while doing this research was that most people that were interviewed from companies within a migration process that are on it for the last 2 years said that they consistently have something like 20% more effort on each feature, but they have the return in terms of maintainability, and that the return on investment overall is proven to be quite stable if you do your design right. So how did we come up with the migration steps so far, and what I think is important there? So if we're talking about new features and features for optimization, these are the things that bring value. Everything else is just repeating what you already have. So we try to always marry them somehow. Everything that has some value, and we were super excited about, and operations from the warehouse were asking about it. We want to also marry with some migration of something that's already there. And out of that, we kind of came up with a list of steps and tried to rank them by value, but also taking into consideration the size of the project, so not to start with something too big, and also the way they improve your design. So if you find some of those steps that would make it easily visible that your platform design and the domain objects that you came up with make sense, then pick that first if the value is comparable. Okay, so trade-offs. These are also like the standard trade-offs that are cited usually for microservices migration. We have some of them I think we've tackled better than others. For example, for Conway's law, we are restructuring the whole department because the way the layers of the system would function does not map with the previous structure. And now we have these three pillars where you would have the core of the system and then the algorithmic part and the executor part, and that is what we're sticking with. Overall, for Technicals Pro, I think there was some kind of critical time in the beginning where the whole migration was announced when teams started doing whatever they wanted with whatever technology they want, and we have some stuff there that we actually need to replace, unfortunately, because of the loss of know-how and because of the way they were done. Quite a few of the services were not done up to any standard, not in an understandable way. Their size is too big. They're too tight to their use cases, and unfortunately, quite a bit was done there, kind of at the start of this, that wasn't so thought out. Yeah. In terms of abilities of system to fail, what we do there, we try to come up with ways to review the whole design quite often, because otherwise it's hard to keep that in check. And we've seen that for some teams, it's also something that people don't forget to think about when we have the whole idea of, okay, how everything is going to communicate with each other. And we say at some point, okay, it looks fine, it would work. And then if you start imagining where things getting delayed or parts of the service being unavailable, then it might be quite a trade-off. For competitiveness for engineering and infrastructure resources, we're not really at this stage, to be honest, because we're just in the beginning of the migration. So the two things left, things we did well and things we didn't do so well, I think. For what we did well, I think the decision to move to microservices was not made because it's cool or because it's time, everyone's doing it, but it was really made mapped to the business value and why it makes sense for Zalando. We also have a lot of management support. The understanding of why we're doing this on SVP level and on the level of the warehouse management heads is actually pretty good. And when we're talking about warehouse leads, it's hard to break them down for them. What is this system and why are we onboarding a project for the last year and a half and they haven't seen anything yet. But they do understand that this would give us flexibility in the future, and they actually promote it. I think that's really key, otherwise it's easy to fail. There are so many things to keep in mind that if somebody is scrutinizing your every move, you won't have the time to be successful. We also try to marry every step of the migration with some value, and I think that gives this idea of, okay, now we're delivering this, we have this parameter better, a few more months, and then we'll have some improvement on the other KPI, and then they also have, with every stage, some idea of what we're improving, not only of, okay, we are promising a very bright future, but now nothing is going to happen. We also try to, for the bigger concepts in the system, we try to push them away as much as we can. The example I have there, so we are now implementing, as I told you, this project where things are sorted from the both machines. And we thought about, should we include prioritization of the orders, and should we include error handling and what we do after we find errors in the process there. And we didn't, we actually pushed them away. For the warehouse, it means a little bit of inefficiency at the end of the process. But for us, it means that we have enough time to come up with concepts that would be general enough and that would actually support all the use cases better in the future. We also know what hacks we did to make it happen, and we try to remember the hacks so we know where the technical debt is. We have architectural groups in all the pillars, and we discuss quite a bit there. Each of the developers that works in the teams, or almost each of the developers, does some concept work and proposes solutions, and we discuss whenever we can on them. It's not, I think this type of work in isolation is not really easy to do. And you need to have this culture of talking about it and owning the design, which we do have an architect that does that, but it's good when everyone in the teams also has this mindset. We took some time for workshops for the whole design and planning, and we also have a very proactive culture overall. So people do care about the product. They don't just get tickets of what needs to be done next. And I think that that's really key for this type of migration. What I wanted to do better, I wanted to maybe take up a smaller project. So the project we were working on now started 1 year and 3 months ago, and we will deliver next month. It could have been much smaller. We could have taken, for example, one of the pilots for the new automation and just set up a couple of processes and see if they're efficient enough, because the pilots anyway need to just check if the units per hour rates are high enough for us to buy them. And we could have done that instead of just a huge process that needs to go live and operational. But yeah. Optimism bias is a big thing as well, and kind of knowing your own capabilities, because the first time this backsorter machine was implemented with a set of microservices, we thought we can do it really well. Nobody said to think about it. And we didn't do it well. Of course, it took some more time than expected. And now, for a second time, we're taking much more time than we estimated in the beginning. I think in the beginning, we thought 6 to 8 months, and we'll be done with this. And now it's like 1 year and 4 months. For the future, I really feel that we're still at the start. There's quite a lot to do. Just if you measure that in how many processes are onboarded to the system, there's still a lot. There's all the processes that are the normal automation processes, all the unautomated processes, the shipping ones, everything for receive. I think it would be at least easily 2 more years of migration. But at the end, what we want to deliver is a way to inspire the business to be more flexible and give them tools to design their processes in ways that are closer to what they want to test and improve for each automation. Because when you can do that, you have those tweaks of really squeezing the last mile of efficiency of every process and every automation that you bought. And when you have a very kind of strict system, it's not easy to achieve. Okay, just as a summary, what I wanted to leave you with is really whenever you migrate, whatever you try to split from your monolith, think about why are you doing it? How does it fit the business? Whenever you plan the migration, make sure it fits the business as well and delivers value in every step. be mindful of the trade-offs and kind of try to really know yourself a bit better so you don't overestimate or you don't kind of start doing without designing, without thinking that you need to plan too much. So that's from me. These are my contacts. You can tell me about your own stories. You can tell me if you disagree with something, if you agree with something. Would be thrilled to hear that. And now I think we have a little bit time for questions. Yes, actually the teams have been changed quite a few times in the algorithmic part. In the core is currently forming, so there is a new team that was that is there for almost 2 years for the process part of things, but for the inventories and the tasks, there are 2 teams already owning the parts of the monolith that does that, and they own the new services as well. But we restructured in a way that those 3 teams work closer together. But yeah, there is quite a bit of restructuring needed, for sure. Yep.
Regarding the development model, I believe that you guys use functional reactive programming. Can you comment a little bit of that, or is it something that you're familiar with?
No, we don't use functional programming for everything. We have a few services in Scala. We unfortunately have something in Node.js, but everything else is in Java. Thank you.